Hi, good evening students. So yesterday we was discussed about a number system. It is a very lengthy chapter. In that beginning subtopic is types of numbers. Mainly we have to discuss 8 types of numbers. Among that 8 numbers, already in day 1 class, nothing but yesterday, we discussed about natural whole integers. 3 numbers are completed. Now present 5 more balance there. So today we have to discuss 5 more types of numbers. Very perfect, no doubt. Let us see one by one. So first, fourth type of numbers are rational numbers. Maximum students, they are able to get confused about rationals. They are unable to give proper answer about rationals. Please try to understand. Clearly, you must and should focus on this definition. You clearly observe this definition. I am also going to observe this definition, but you observe along with me. What we are discussing, just concentrate towards the board. Right. See, now I am writing few examples. See carefully, definition. I am giving clear in details about definition. What is the definition actually? See, numbers. Till you know natural number, whole number, integers. Now you are ready to learn about rational numbers. In a sense, numbers which we know already in the previous video. Natural whole integers now. Among these natural whole integers, you choose numbers. Simple. You choose natural numbers or whole numbers or integers which we learned in the previous section, previous class. Okay, very clear. We have to choose the numbers which are related to natural whole integers. For example, I think you got very clear that here we have to choose natural number or else whole number or else integers. No doubt, clearly observe carefully. So I want to take one number from natural, that is about 2. 2 belongs to natural number. Then I want to take one more number from whole. In that whole, let us go with 0. 0 belongs to whole number. I think, okay. Now next moment is integers. In that you take just 5. 5. See, I took one is from natural, one is from whole, last one is from integers. I took 3 numbers from 3 different sets. One is from natural, one is whole, one is integer. Carefully observe my words, observe my voice, observe carefully. Okay, I took 3 numbers which are expressed or written. What is that? What is the meaning of that? I took numbers now which are expressed or written in the form of P by Q. In a sense, they are not P by Q form. See, clearly observe. Those are not P by Q form. According to definition, 2 number 0 minus 5 are going to return, are going to express in the form of P by Q form. Now I want to show that. How? Those values we can convert P by Q form. Right. 2 there. 2 by 1. What happened? What happened? See. Natural number is expressed or written in the form of P by Q form. 1 more. 4 by 2. See once. See back. To 1 the to 2 the. You will get same 2. Next. 6 by 3. Same. Next. 10 by 5. 5 1 the 5 2 the same. Like that. We can write infinity. Once again go to the definition. 2 is a natural number. We express it in the form of p by q. That means 2 is a natural number. We express it in the form of p by q. But thing is, two conditions are there where p and qr belongs to integers. Once you think about the condition, here p position 2 there, q position 1 there, nothing but 2, 1 integers only. 4, 2 integers. 6, 3 integers. 10, 5 also integers. Condition is perfect. Let us go with another condition that q not equal to 0. See where it is q equal to 0. Is it 0? No. 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 There also no. Mean clearly observe. 2 is natural. We express it in the form of p by q under these two conditions. I think everybody understood very clear. Think about 0, which is part of the word. Same. 0 by 1, 0 only. 0 by 2, 0 only. 0 by 10, 0 only. 0 by 100, 0 only. Like that we can write many. Here also the same things. 0 is a whole number. We express it in the form of p by q under two conditions. See, p, q are integers. 0, 1 are integers. 0, 2 integers. 0, 10 integers. 0, 100 also integers. And the denominator is not 0. Not. Now, let us think about minus 5, which is part of the integers. So, minus 5 also we can. Minus 5 by 1, minus 10 by 2, minus 15 by 3, minus 20 by 4. Like this, we can extend infinity. See, natural numbers, whole numbers, even integers also going to express can be written in the form of p by q under these two conditions or not? Exactly yes. Exactly yes, we can express. Are known as rational number. What you understood, tell me? What you understood? Through the definition, 2, 0, minus 5 are the rationals, 100% rationals only. 2 is a rational number, 0 is a rational number, even minus 5 also rational number according to the definition. Not only that, clearly observe, carefully try to understand. See, I am explaining few more things about this. 2 is part of the natural, 2 is also one of the rational. When 2 is the rational number, statement observe. All natural numbers are numbers can be expressed in the form of p by q, where p and q are integers, q not equal to 0. In a sense, all natural numbers are rational numbers. Right. Actually, what we have to discuss that natural numbers. See, 2 is a natural number. We converted in the form of p by q under these two conditions, so that 2 is called a rational number. Through this small example, we conclude that all natural numbers are whole numbers because of we can express in p by q form under these two conditions. No doubt. Even though all whole numbers are also rational numbers because all whole numbers are also going to express in the form of p by q form under these two conditions. And all integers also called as rationals. Reason we can express in the form of p by q, where p, q are integer, q not equal to 0. See students, carefully observe what is going on. All natural numbers, whole numbers and integers are known as rational numbers. Don't forget this. Reason? Natural numbers, whole numbers, integers we can express in the form of p by q form, where p and q are integers, q not equal to 0. That is the reason. So finally I am concluding that all natural numbers, whole numbers, integers are known as rational numbers. Oh, very good. You know very well. All natural numbers, whole numbers, integers are rationals. No doubt. Next, few more things about rationals. The fourth position observe. If I am giving like this 1 by 2. See, first number completed, second completed, third completed. But once try to observe this one. Try to observe this one. That is 1 by 2. But what about this name? What about its name? Already p by q form there. Already p by q form there. So that reason this is we can call as rational number. 1 by 2 is called as a rational number. Next, one more example I am giving that. -2 minus 5. What is this? It is also one of the rational. Once try to observe, it is in the form of p by q, and p and q are integers. Yes, -2 minus 5 are integers. Q not equal to 0. Not there. Denominator not there 0. Even though -2 by -5 also rational number only. Next, -2 by 7. It is also rational. Observe conditions of the p by q form there. P and q are integers. -2, 7 are integers, and the denominator is not equal to 0. Not there. Next, -5. Better to take 5 and -3. It is also one of the rational number. Now I want to give some more examples that 1 whole 1 by 2. Students, I am giving total different numbers. 1 whole 1 by 2. It is also one of the rational number. But you will get one doubt. Sir, it is not p by q form. No, not there. I want to accept your doubt. Not there. But we can express. How? 2 ones are 2. 2 plus 1, 3. 3 by 2. Conversion according to definition, which is not direct in p by q form, we can express. So that 1 by 2, 1 whole 1 by 2 is going to convert 3 by 2. In a sense, 1 whole 1 by 2 is 100% rational number only. Now one more. 0.5 is also rational number. Sir, p by q form not there, no? I know. P by q form not there. But according to definition, we can express p by q form now. Yes, 1c. This can be written as 5 by 10. 5 ones or 5 twos or what is answer? 1 by 2. Yes, 0.5 is converted p by q form. Carefully observe, carefully. 0.5 also one of the rational. One more, last example I am writing here. 0.5 are there. It is also one of the rational number only. You will raise one doubt. Sir, it is not p by q form. No. We can express according to definition. We can express in p by q form. Like this, you know, 5 by 9. 5 by 9 answer 0.5 only, no. What happens? 0.5 is equal to 5 by 9. Nothing but 0.5 decimal is converted to p by q form, expressed in p by q form. So that reason 0.5 bar is also one of the rational number only. Right. Definition very clear. Once shortly I can discuss. Rational number definition is perfect definition, this one. But maximum you try to filter the definition. Numbers, natural whole integers, can be expressed in the form of p by q form. So that reason all natural numbers, whole numbers, integers are rational numbers, no doubt. And these observe carefully. These values, examples observe. It is already p by q form rational. It is 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 not p by q form, but we can convert. So that 1 whole 1 by 2 is also rational. It is not p by q form, but we can convert. So that 0.5 is also rational. 0.5 bar is not p by q form, but we can convert p by q form. Right, here many examples are there of rational numbers. Right, students, I want to discuss few more things about rational numbers. 1. Points by C. 1. Rationals or else rational numbers are also called as question numbers. Question numbers. Carefully observe beta. Everyone, every student. Very important. Rational numbers are also called as question numbers. Second. Rationals are denoted by only q letter, but not r. Here r letter there no, here q letter there no. Among these two letters we can use only q letter to denote the rationals, but we cannot denote with r. You have doubt, why not r? See, once go to the real number. Real number has single name, so that real numbers are denoted with only capital R. Here capital R, there capital R. You will face the problem. So that reason, real numbers are denoted by capital R. Rational numbers are denoted by only Q instead of R. To be clarity, so rationals are denoted by Q. Real numbers are denoted by R. There is two names there. There is single name. So rationals are denoted by capital R. Real numbers are denoted by capital R. Rational numbers are denoted by capital Q instead of capital R. And one more thing I want to discuss. Right, I think you got it about the rational number, clear cut information. Let us go with another thing is, okay, right. Next, fifth type of numbers are irrationals. Irrationals, carefully observe. I can design these irrational numbers into two categories. Carefully observe, students. Basics are very important in our mathematics. Without basics, we cannot perform very well. So that irrationals, we made two parts. See, what are they? That means non-terminating, non-repeating decimal. Once again, non-terminating, non-repeating decimal. Shortcut NTNRD. Once see now. NTNRD, in a sense, non-terminating, non-repeating decimals. Once again, non-terminating, non-repeating decimals. And one more set, see, nth root of a, where conditions observe carefully, where number 1, n not equal to 0 and n is belongs to natural. And one more reason, a is belongs to positive rational. And the third one, a cannot be expressed as the power n. Observe carefully. Irrational numbers are categorized two. One is NT, nothing but non-terminating, non-repeating decimals are called irrations. Simple. One more. Nth root of A. Nth root of A form values are called irrationals, but with three conditions. What is first one? N value is not equal to 1, as well as it is must and should part of the natural number. And second condition, A belongs to positive rational number. Third condition, A cannot be expressed as the power of n. In a sense, I want to say that, I want to be clarity. You see, n value not equal to 1 means we never consider n value is 1. But n value is part of the natural, nothing but natural numbers are 1, 2, 3, 4, 5, so many there. In that n value should not consider 1. Let us go with 2. Now I am writing 2. This one, fourth, n. See, about I am speaking about n. What is n? N value should not 1. That is part of the natural. In a sense, n value is considered 2, 3, 4, 5 till n. That's why second root, third root, fourth root, nth root. Based on this condition, this nth root A should be in this form under the first condition. And go to the second condition. Let it be 2, but A must be, and Q value, A value must be positive rational. Till we discussed about rationals now. Among that rationals, you should consider only positive values. For example, like 4, no, it is not possible. Let us think 3. Next, cube root of 10. Next, fourth root of 1 by 2. Like this, we can take many examples based on the second condition. A value is part of the positive rational, nothing but 3 is positive rational only. 10 is also positive. 1 by 2 is also positive rational numbers. In such a way, you have to choose Q value, A value. Now, what is third condition? Inside A, and here, inside A cannot be expressed as the power of n. In a sense, one small example observe. Suppose 2 second root of, if I am writing 4 there, how can we express this second root of 2, 4, 2? What happened there? N position 2 there, and inside value A is expressed as a power of n. See, inside, upside, exponent to in this n position. N value, exponent of the A. They should not be equal. If they are equal, what will happen? Tell me. They are going to cancel. Now you are able to get answer is rational. But our topic is irrational. No. If you be with irrational number, we cannot express with same exponent which is equal to n. Nothing but this exponent to n position value. They never same. They should not be equal. They should not be equal. Then only the, for example, square root of suppose 3. 3 we cannot express as a power 2, as an exponent 2. That's why square root 2 is part of irrational concept. It is the best example of the irrational number, which is in the form of nth root of A under these 3 cases. See, once you cases observe, square root of 3 observe carefully. N value is not equal to 1, not there. It is belongs to n. Yes, 2 is belongs to n. Next, second case, A value is compulsory. 100% is positive rational number. Yes, 3 is positive rational number only. Third condition, 3 cannot be expressed as a power of n. Here n position 2 there. Mean we cannot express 3 as a power of 2. Mean this is best example which is in the form of nth root a under these 3 cases. Once you observe carefully, irrational numbers are divided two categories. One is non-terminating, non-repeating decimals. I want to give few examples to understand that. 0.10, 110, 1110, dot dot dot. One more example I want to give. 10.01, 001, 0001, 00001, like that. Mean these are called non-terminating, non-repeating decimals. So these are best examples of irrational. These are called irrational numbers. And one more side, nth root of a. The numbers which are in the form of nth root of a under based on these 3 conditions, those are also part of the irrationals only. Once again, conclusion. Irrational numbers nothing but the common, carefully students, irrational numbers are nothing but the combination of non-terminating, non-repeating decimals and the numbers which are in the form of nth root of a, where this condition, then those are called irrationals. Mean these two are irrationals. Square root 3 also irrationals. Square root 3 irrationals. Cube root 10 irrationals. Fourth root of 1 by 2 is also irrationals. Students, I think you understood what are the irrationals. Okay. And one more thing, very important thing, that carefully observe, carefully. Nth root of a there, no? Nth root of a, however, irrational based on these 3 conditions. But one doubt, that is, see, let us go with the second movement. What is that? If a belongs to negative rational, okay, this point I want to discuss further when we are discussing imaginary numbers. Okay, just leave it. So a belongs to negative rationals. Further we will discuss. It is not necessary now. Further, nothing but after real numbers we can discuss about imaginary. At the situation we can choose this concept. Based on that we can introduce imaginary numbers. Okay. Right. Okay. Next, one more very important thing. Please don't neglect, students. What is that? See, this side once as a note. I want to mention as a note that the numbers which are in the form of nth root a. Now I am erasing this. The numbers which are in the form of nth root a based on these 3 conditions. Once again. Be careful. The numbers which are in the form of nth root a based on these 3 conditions are also called as surds. S-U-R-D-S. Very important topic it is. Once again. The numbers which are in the form of nth root a based on these 3 conditions are also called as surds. Don't neglect. I told 2-3 times because I know its importance. Okay, you got it, very clear idea about it. But I want to pass small questions over. Small questions, just like statements. See, carefully observe. These all surds All suds are irrationals. All suds are irrationals. All non-terminating, non-repeating decimals are irrationals. Carefully, be attention. Irrational is nothing but the combination of non-terminating, non-repeating decimals and the numbers which are in the form of nth root a based on these three conditions are known as irrational numbers. In that irrational numbers, the numbers which are in the form of nth root a based on these three conditions are also called as suds. Now tell me, in this, all suds are irrational numbers, but all irrational numbers are maybe suds. All irrational numbers are maybe suds. Maybe. Sometimes all irrationals may be suds. Sentence is very important. Once again I will remind you. All suds are irrationals, but all irrationals need not to be suds. I think everybody got about irrational numbers. One more important thing. Irrational numbers are completely denoted with Q complement. Here, this line observe. This is called complement. Complement. You can read as complement. Once again, irrational numbers are denoted with Q complement. How to read this? Q complement. It is completely opposite to rational. Rationals are denoted with Q. Irrationals are denoted with Q complement. You got clear idea? Then, okay. Right, okay. Sixth type of numbers are real numbers. Real numbers. Simple thing, please. I want to give very clearly and very shortly. What is that? Real numbers. There is no another name of the real number. The real number has single name. There is no another name. Remind this one. That's why real numbers are denoted with only beginning letter, that is R. Second, real numbers is nothing but the combination of, once again, the combination of rational numbers and irrational numbers are known as real numbers. Very simple. I told you two things. Real numbers have single name. There is no another name. So that reason, real numbers are denoted with only capital R. Only capital R. And real number proper definition is the combination of rational numbers and irrational numbers is known as the set of real numbers. Now I want to give few examples under this title of real number. Example set observe. I am giving examples. What are the examples now? See, 2 real number only. Now minus 2 real number only. Now 0 real number only. 1 by 2 real number only. 0.5 real number only. 0.1 bar real number only. 1 whole 1 by 2 real number. I think everybody got it. Next, minus 2 by minus 3 real number. Minus 2 by 5 real number. Minus 4 by minus 3 real number. Observe carefully. I am giving just examples. Right. Some more examples are there, different examples. Okay, try to understand. Right. 0.01, 001, 0001, ... This is also one of the real number only. Next, square root 2 real number only. Next cube root 2 real number only. Now fourth root 2 real number, fifth root 2 real number. Next 10th root 2 real number only. Now 10th root 5 real number only. Square root of 2, it is a real number only. Some different there. Different there. This is also one of the real number only. See, etc. See, these are perfect example of real numbers. In these real numbers example side, some rationals there, some irrationals there. Now rational numbers I can make round, irrational numbers I cannot make round. Once try to understand. Now I am rounding the rational numbers. Yes, 2 is rational, minus 2 is rational, 0 is rational, 1 by 2 is rational, 0.5 is rational, 0.1 bar is rational, 1 whole 1 by 2 is rational, minus 2 by minus 3 is rational, minus 2 by minus 2 by 5 is rational, 4 by minus 3 is rational. These rounded values are part of the Q, nothing but rational. Now Q bar, nothing but irrational side. See, this is irrational number, this is irrational, this is irrational, 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 etc. See, carefully observe. When these two types of numbers are together, yes, you observe carefully. The union of rational and irrational is known as real number. Students, today we discussed about rational numbers, irrational numbers, real numbers. Three types of numbers discussed today itself. I think, I hope everybody understood. If you have any doubts, please comment to me. Comment in the comment box. And one more thing, one more request. Just share my video and make like and subscribe. Further video, daily we can pass one video based on the basics of mathematics, exciting without any doubt, perfect. Actually behind that main intention is, main aim is, main reason is, I am going to give proper details about the concept. I hope you can understand by listening this, so that I am daily one video I am just arranging and I am passing the videos. Please see the video and like it and share it and subscribe it. Don't just because of it is just a support to me, that's it. Definitely I can pass few more details further classes.